Konnichiwa, watashi no namae wa Mahitiagi. I am a student from Amity University. The problem statement that I've chosen is Factory Intelligence by Geolif. Focusing on the problem statement, I have devised a solution which is both a technical and a business model. Let's look at the problematic factors that the Japanese SMEs are facing today. A major contributor to this problem would be the aging population. Around 30% to 60% of the Japanese population is about to retire in a few years or is above the age of 60. Hence, they are not able to fulfill the high demands. But this chunk of population is the most talented and highly equipped. They have the tacit knowledge and the craftsmanship, which is now at the risk of loss and being forgotten. Another problem is the business succession crisis and skilled labor shortage. This is because the younger generations are moving towards urbanization. This leads to the cultural, economical, and technological hurdles. Many Japanese factories and small businesses often resist the rapid digital transformation. Many continue the legacy systems and the conservative business approach. This might be due to the management commitment, the lack of capital, and the fear of compromising their trust, craftsmanship, and product quality. Japan is also facing a huge global competition with countries like China and Southeast Asia, who excel in producing large amounts of supplies at cheaper rates. It is making it harder for these businesses to sustain for a longer period of time. Now, let's look at the proposed solutions. We have a knowledge capturing system. We can enhance the operations using IoT devices and predictive analysis for maintenance, efficiency, and cost control. Geomapping using GPS or GIS can be used to access all the areas of the factories, including the warehouse, storage rooms, testing labs, meeting rooms, and the inlets and outlets. To expand business and invite profit, a B2B cloud platform will be accessible to these businesses and factories to reach their niche buyers globally. I will now take you through the workflow that I created in detail. This model will be first trained based on the skill set of the highly professional and experienced workers. Then the data points would be captured from them, and this system would be ready to train the new workers. Let's see how. First, the task is allocated to the worker based on their areas of interest and specialty. While the task is being performed, it is being captured using IoT sensors and computer vision. This data is now analyzed and authenticated at the backend using deep learning models. At this point, it gets divided into two parts based on the nature of the task. If the task is repetitive or easy and can be done by the machines, it is automated using artificial intelligence. But if the task is manual and non-repetitive, has a lot of ambiguity, and is possible through various styles with a variety of combinations, it is recorded in the database schemas. Now comes the sequential checklist verification and comparison that happens side by side. If the checklist is complete and the performed task gives the best output with least error using regression or classification models, then this knowledge or skill is transmitted towards helping the new workers learn through artificial intelligence and natural language processing. In the extreme right, as you can see, there is an alert symbol which represents that if after the authentication of the data points, if the work is not properly performed or is missing something from the steps, or there is an unusual activity detected, either the work was being done by the machine or the workers, the task has to be redone and there would be a need of human supervision. Here comes the concept of semantic anomaly detection, an alert system which is made using the AI-powered host-based detection for hardware devices or softwares that gives semantic explanation in a human-understood format for the anomalies and the unknown hidden spikes that occurred in the machine, device, or software. At the bottom of the workflow, I have incorporated a smart and efficient AI tracker that records the daily work schedule, in time and out time of the workers, which also stores the data about the output they have produced. If the work hours to the performance ratio is equal or greater than the threshold of a factory, then it is considered efficient. The machines and workers are put to a state of rest automatically. But if the ratio is lesser than the threshold, the worker has to practice the module again until their scores are satisfactory. Until then, the machines will continue the process. As this model is trained by highly skilled and professional industry workers, it will not lead to the wastage of resources if the inefficient workers create low quality products in a huge bulk. This is because the model learns quickly and leads to minimum possible chances of error, hence reducing the wastage of resources. After receiving the final product, we can sell it in the global market using social media, influencer marketing, or by creating a niche market using trends. This is a popular approach and a more accepted one by the younger generations of Japan. This will strengthen the export relations of Japan with the other countries. And with this, we come to the conclusion of the workflow as well as the presentation. Let's empower Japan together. Thank you.